Nous sommes go pour la mise à feu. H-.
15, 14, 13, 12, 11, 10, 9, 8, 7, 6. Départ séquence mise à feu. 1. Mise à feu.
Front row seat for the launch of the Jupiter Icy Moons Explorer on an Ariane 5 rocket.
Our rocket is here on the launch pad with the JUICE spacecraft on top, ready to begin its journey.
Over the next couple of hours, we will bring you live coverage of launch operations directly from here.
The Jupiter Control Center.
And from here, ESA's mission control at the European Space Operations Center in Germany.
So this is where we're getting the first signals from the spacecraft after launch and confirmation that the solar panels have deployed. We'll be discussing exactly what makes this spacecraft so special. I'm Matt Russell.
I'm Bruno Souza.
I'm Raphael Chevrier.
And I'm Lisa Peterson, and welcome to flight VA260 on the first leg of JUICE's journey into space. Following yesterday's postponement due to bad weather, Ariane 5 is now ready for launch here at Europe's spaceport in French Guiana. With her single passenger, the Jupiter Icy Moons Explorer, JUICE, safe and sound under the fairing. Liftoff is scheduled in just under half an hour. I'm right here in the aptly named Jupiter Mission Control Room. This is the nerve center of today's mission, and you can see here on the other side of this protective glass, which we call the fishbowl here in Kourou, you can see the teams working hard on the last preparations towards today's mission. Opposite me here, we have the partners, VIPs, and guests all comfortably seated and waiting for liftoff. And with me right here for an update, we have Stéphane Israël, CEO of Ariane Space. Welcome, Stéphane.
Good morning, please.
Thank you very much. So we're back here together. So can you first of all maybe tell me, 24-hour delay, what was the reason for this delay yesterday?
So very simple. The launcher was ready, JUICE was ready, the launch was ready, but the weather was not with us. You know, we have to monitor two risks. High altitude winds, and it was okay, but risk of lightning yesterday was a real risk with the cloud to monitor, and so we have made the decision not to lift off yesterday.
But of course, as we always say, better be safe than sorry. JUICE can absolutely afford to wait another day under the fairing, not a problem.
Yes, for sure, because you know that once we will have done our job after 27 minutes and once we will have orbited JUICE on an escape orbit, then it will be the start of an 8-year journey. So one day is nothing as compared to what we have ahead of us. We will monitor the weather now in the final minutes. The teams have worked all night. All is red up to now, so we are now... All is green up to now, sorry.
And we can see it on the status board, and we get some clapping here from the crowd.
It's a part of emotion for such an important mission.
It's going to bring us very good luck.
Yes,
absolutely.
All is green. And so at 9:14, we will lift off.
At 9:14, we'll lift off. Thank you so much, Stéphane, and fingers crossed, good luck for today. And we'll see you later. Thank you so much, Stéphane. And Stéphane is getting a round of applause in here in Jupiter. Of course, an emotion which is easy to understand, obviously, considering the conditions of yesterday's delay. But everything is fine, safe and sound under the fairing, as we said. So, as the teams working here in Jupiter Control, more than 7,000 kilometers away over the Atlantic at ESA's Mission Control Center in Darmstadt, Germany, we have the teams there who will take over control of the aircraft once it separates from the mothership. And we're going to go straight over and speak to them and hear how things are looking over there in Darmstadt. Over to you, Matt.
Thank you, Lisa, and hello to all our watchers. Welcome to ESOC, the European Space Operations Centre, here in Darmstadt, Germany, in the heart of Mission Control. I am. My name is Matt Russell, and I will be your host for the second half of this JUICE broadcast. And behind, we have Bruno Souza in the actual control room itself. So, hello, Bruno. Try and give us an update of what's happening in there at the moment.
Hi, Matt. We're still getting goosebumps all day, although to this time a bit more cautious goosebumps. But we are ready to go. And in fact, just a few minutes ago, the flight director, Andrea Komatsu, just did the roll call and got to go from everybody here in the room. We have some footage of that, and we're going to replay it for you.
To all stations, this is OD on the briefing loop for the roll call. Please reply on my call with your call sign and your status, go, no, go. OM.
OM.
Go. Some go. Data handling.
And data handling go.
EOCS.
EOCS go.
Platform.
Platform go.
Flight dynamics.
Flight dynamics go.
Project rep.
Project rep go.
Project support.
Project support go.
Softcode.
Softcode go.
Software support.
Software support go.
S-track.
Extra go.
Scheduling.
Scheduling go.
Thanks. This completes the roll call for the JUICE mission. We are go for launch.
So as you just saw, we are fully ready to go. We're just waiting for that rocket to get off the launch pad.
Thanks so much, Bruno. Well, we're running out of time here, so we're back over to you, Lisa, in Kourou, and massive good luck to you.
Thank you from the teams in Darmstadt. And hey, the pressure's on. They said all we're waiting for is that rocket to take off. Well, they've told us they're ready. The rocket is ready, but we want to know about JUICE. And we have Mihaela Barbu from ESA who's here to tell us all about it. Mihaela, how ready is JUICE?
Good morning. JUICE is actually ready and excited to start this journey. As we speak, my colleagues are closely monitoring the satellite. So yesterday, after the launch postponement, the satellite was switched off. And slowly in the day, around 7:14 p.m., it has been turned on to start the countdown procedure. They are very close to us, a few kilometers away in LBC control room, and everyone is hoping for good weather specs.
Fantastic. So we have a bit of time to chat about this. So your job is schedule controller. Does that mean that you're in charge of making sure all goes to plan?
It's part of my responsibility, but you know, when it comes to scheduling, it's never one single person's job. It's actually a team exercise because planning means working coherently as a team. And us, the JUICE project team, we are quite schedule-oriented. We have a strong planning mindset. And even if you have the most perfect plan, you always have risk, you have uncertainty. And we saw that yesterday. So imagine if you take a step back, us in JUICE, we had to run our AIT campaign through a pandemic. And if you think of the industrial consortium, more than 2,000 people worked on this program, 23 countries, 18 institutions, 83 companies, then you understand the complexity of project management that my colleagues and I have been performed on this mission.
And done a fantastic job so far. So this is a personal journey for you. It's 8 years, your entire professional life, because you're just a baby. So tell us how you're feeling today.
I'm very excited, and yes, JUICE is my entire career in ESA. And yesterday, as the project team, we received so much positive energy from home, from our science project. Thank you so much for your wishes. Everyone in ESTEC, we saw you how many were there. Thank you for your support. ESOC, ESAC, the people on the spaceport, we managed to see our extended JUICE family, our instrument colleagues, and we spoke with them. So they gave us all the energy to go through the night and to keep JUICE ready for the launch today.
Thank you so much. Have you got a last word before we leave it here?
I wish everyone to enjoy the launch from all the teams who have worked on this amazing journey. As European, I'm exceptionally proud to be part of it. And let's enjoy the event of today. It's well deserved.
Absolutely well deserved. for your teams and, of course, all the other teams that you mentioned that have been working on this project. Thank you so much, Mihaela. Thank you. So, as Mihaela was saying, a huge amount of work from teams all over the world. We're going to find out more about these teams' achievements and, of course, about JUICE in the next film.
Jupiter, the largest planet in the solar system, is a place that holds many secrets. This fascinating gas giant planet and its intriguing moons have raised more questions than answers. Today, these answers are in ESA's grasp, with the very first European mission to Jupiter, JUICE. Short for Jupiter Icy Moons Explorer, this spacecraft will explore Jupiter and 3 of its icy moons, Callisto, Europa, and in particular Ganymede. Developed and built by Airbus, JUICE's spacecraft is equipped with 10 top-of-the-line science instruments to explore the Jovian system and investigate whether some of its many environments may be suitable for the formation of life. This grand odyssey of exploration begins with the launch of JUICE on an Ariane 5 rocket from Europe's spaceport in Kourou, an historical mission aiming at solving key mysteries such as the possibility of life in the Jovian system, Ganymede's magnetic field, and last but not least, the formation of Jupiter and its moons. JUICE will also study Jupiter's complex weather, chemistry, and climate in detail.
It's a very fantastic mission from the scientific point of view. Very broad science, very interdisciplinary science. We would like to see whether around Jupiter there are places where life could have started. To explore that, we need to find a place with internal energy and with liquid water. And inside the icy moons, we have good reason to believe that there is in fact more liquid water there inside the surface than on Earth.
JUICE is expected to arrive at Jupiter in 2031 and will then make its Jupiter tour and moon's flybys before orbiting Ganymede. This will be the first time a spacecraft orbits any moon other than our own. During its journey, JUICE will face many dangers such as Jupiter's intense radiation belts or its large gravitational pull, but these dangers will be worth it for the science that JUICE will uncover. The gas giant will reveal some of its many secrets in 2032 when the first data will be available. Watch this space.
So speaking of space exploration, we have 2 of the faces of human space exploration with us here today. I'm delighted to welcome once again Thomas Pesquet and Matthias Maurer. Thank you very much, gentlemen, for being with us again today. It's a pleasure. So we're seeing JUICE go up into space with these outstanding instruments. What is it about sending this kind of instrument, going out to space yourselves, that helps us back here on Earth? First question to you.
Yeah, I think space exploration really in space ticks all the boxes. You've got all the short-term benefits, the things that we all use, that we all have in our smartphones, the navigation, the weather report. And then you have the more medium-term, I would say, applications. The reason we know today about climate change, the reason we're in position to fight climate change is thanks to all the missions we send around the Earth and observing the Earth. So that's kind of the more medium terms. Space agencies are the champions of fighting against climate change. And then you have the longer term, the far-reaching benefits for the future. And that's the research and the exploration we're doing, the research on board the space station, building better materials, better medicine, better treatments. And it all diffuses in society on Earth and it's going to make the progress, go up one step at a time. And then those missions going far out into the solar system, it's really to look at ourselves, our place in the universe, how do planets form, where do we come from, where are we going? Those are very important questions, and those are the type of questions that we're trying to solve with those missions.
Fantastic. Well, we're talking about JUICE today that's about to lift off and go on its mission, a long journey. But what about human space exploration? What are the next destinations?
Well, I think the next destination is very much the moon. I mean, the next big thing in space exploration, human space exploration, is the Artemis program. ESA has a big part to play in the Artemis program. We're providing the European service module to the Orion capsule. And that means one day we'll see European astronauts around the moon, on the moon. And so to prepare for this, we also have our robotic moon exploration. And then what we learn on the moon will put us in a position one day to go to Mars. And Mars is the twin sister of the Earth. That's where we learn a lot on ourselves. It had similar conditions. It has lost its atmosphere. Liquid water also has disappeared. Can it happen to us? Those are important questions. And that's why we'll go to Mars first with our probes, with our orbiters, and then one day with human exploration to Mars. That's the big prize money, the big goal, the big step.
Fantastic. Wow, it makes you dream. But of course, what I would like to know from you, Matthias, is are you guys getting ready to take part in these adventures?
Yes, so Thomas and I, we already flew to a low Earth orbit and flying to the moon. We need to learn more, because on the moon you need geologists. So we need to go out in the field and learn how to talk with the geologist, how to be the hands and the eyes of the geologist once we're on the surface of the moon. And ESA already started this training for European astronauts some years ago. And so we see continuously European astronauts going out into the field, learning all these skills. But we also need to develop facilities where we can train European astronauts what to do on the moon. And so in Cologne, we will now have the moon training facility, which will enable to do all this training over there. And it will be so good that even hopefully the NASA astronauts will come over to train there, for their Artemis mission. So that's the big vision that we have. But it's not only learning for the moon. We also should also keep in focus that we have European astronauts flying to the ISS. Andy Mogensen is getting ready to fly later this year. And we just started a new astronaut class. They will be flying to the ISS, hopefully, and to whatever comes after the ISS.
So do you imagine yourself taking off from here from the European spaceport here in French Guiana one day, Matthias?
Yes, we are currently in times that are really like a revolution in space. And so Europe needs to step up. And one of the big missions that we have, we need to become sovereign, to become autonomous, also with access to space for Europeans from European soil. And I think French Guiana is the ideal place to send Europeans on a European rocket in a European capsule to space. It's our big dream. Thomas and I, we would love to fly together from here to low Earth orbit, but maybe even also in a European rocket further towards the moon.
And you said you'd be happy to welcome your NASA friends as well.
Absolutely. I mean, it's we should not forget spaceflight is also a soft diplomacy power. And we will see very soon that China will invite foreign astronauts to fly to their space station. And so we Europeans, we are just learning that in these times it becomes more and more important to be on level field playing. And spaceflight definitely is also an important part in the diplomacy area.
Huge thank you, Matthias. And we have with us Josef Aschbacher. You are the Director General of ESA. Thank you for joining us. So in a nutshell here, what we've been talking about is Europe's capabilities for independent launch. Are you going to make this happen? You have 15 seconds.
It's not for me to make it happen. It's all the others to make it happen. But certainly we have been working very hard on it. We have consulted experts, independent experts, to help us giving advice what this would mean for Europe as a unity of all the countries, the inspiration we would give, the economic benefits, the geopolitical strength that would be portrayed through such an activity. So there's a lot of interesting facets, and you have just heard Matthias and Thomas talking about those because it's so important, and yes, we're working on it. But let's talk about JUICE because that's why we're here. Also another excellence where Europe is really good, and let's look how our satellites and our launches are doing.
Thank you very much, gentlemen. Huge thank you.
Thank you.
And to talk about JUICE, I am joined by Raphaël Chevrier from Ariane Space. Raphaël is going to take us step by step all the way through every step of the mission. Raphaël.
Hello, Liz.
Hello. Welcome to Road to Space, and I'm going to let you take over from here and tell us what the next steps are.
Yes, so this morning we are launching towards the east, where we benefit from the slingshot effect given by the rotation of the Earth. So the launcher performs a first pitch maneuver in order to get us into the right direction. And only 2 minutes and 17 seconds after liftoff, the two boosters have done their jobs of providing the main thrust, so we don't need them anymore, they are detached from the launcher. Shortly after that, the fairing, which protected the spacecraft from the environment of the launch, is also jettisoned as we have crossed the limits of the atmosphere. Once the launcher reaches an intermediate orbit, the main stage is cut off and separated. So then the upper stage takes over, which engine is going to power for about 16 minutes in order to raise speed and altitude and release juice on the targeted orbit. So, by the way, the little towers that you see on the motion picture, they represent a chain of telemetry stations that are receiving data from the Ariane 5 in real time, all along the flight path. After some orientation maneuvers, JUICE is separated on a liberations orbit. It means that it will have the required speed to escape literally the gravitational pull of the Earth. Then this is almost the end of the mission from the launcher, as we still need to perform some disposal maneuvers of the upper stage, but JUICE is only beginning its journey. ESA teams will use the Norcia ground telemetry stations in Australia to acquire the signal from the spacecraft and take full control of it. 1 hour and a half after liftoff, Joule will start deploying itself like a butterfly into space. First, it will unfold the large solar panels. Their total surface is 85 square meters. This is definitely bigger than my Parisian apartment. And then, in the following days, it will deploy its many antennas and probes. So the animation here doesn't depict the increasing altitude that JUICE is going to getting farther and farther from Earth on its way to its 8-year journey to Jupiter.
Thank you so much, Raphael. It's all very clear. And actually, as Raphael was speaking, so you can see the pictures of Ariane on the launch pad. As Raphael was speaking, we hit the next milestone in our in the chronology, which is, of course, the -10 weather update. And yes, I'm looking at the board. All is green.
All is green right now.
Anything in my earpiece? I don't see anyone picking up a mic. So it's looking good so far.
It is green and we're good to go.
Looking good to go.
What we check, like Stefan said, we are usually checking the wind at high altitude, the wind in the vicinity of the launch pad, and also the risk of lightning. Yesterday, it is the risk of lightning that prevented us from launching, but today, everything's good. We're good to go. We can continue the operations.
That sounds great. And continuing the operations means that we're heading towards what we call the synchronized sequence. We'll talk about that in just a minute. So there's another team. You see the teams working here. Final preparation on the way here in Jupiter Control. But of course, there's another team at the Launch Control Center, which is much closer to the launch. It's about 3-4 kilometers to the launcher. And they've been working since last night. So they've not slept. Tell us more about them.
Well, these teams are monitoring all the operations during the final countdown. So, for example, they are filling the cryogenic stages. They are cooling the Vulcan engine, that's the main engine of the launcher. They are pressurizing the upper stage sphere.
This is them hard at work in the morning.
Exactly, and I think the images were shot this morning actually. And so it's all these operations that are leading us to the start of the synchronized sequence.
So what is this synchronized sequence, Raphael?
Well, it's a really crucial step.
You have 30 seconds.
Yeah, so I'm going to make it very quick. It's basically a succession of operations aimed at giving more and more autonomy to the launcher and to set it in its flight configuration.
Yeah, because
30
it's
seconds.
an irreversible. Once we've started the synchronized sequence, we can't go back.
No, so we are going.
Absolutely. And we're going to now wait and hear.
À tous de DDO, attention pour le début de la séquence finale lanceur. Top H0 moins 7 minutes.
So there we heard it from the DDO, who is the Range Operations Manager. We'll talk about him in a minute. And he's just announced the start of the synchronized sequence. Just a quick question, why does it have to happen at -7? We were just saying.
Well, I mean, this is obviously not a magic number. This is just the time for all these last minute operations to be performed. For example, we are topping up and pressurizing the tanks. We switch the power supply from ground to board, and only then the launcher is going to be fully awakened for launch.
Fantastic. For those who are joining us, we are 6 minutes and 20 seconds to liftoff of Ariane 5, carrying JUICE on the first leg of its journey into space.
Allez, salut à tous. On va partir du coup pour le direct du lancement de l'Ariane 5 de la fusée JUICE. Allez, on va apparaître dans quelques instants à l'écran. Installez-vous, décollage maintenant dans 6 petites minutes.
same. You have the two lateral boosters, you have the main stage, you have the upper stage, one fairing. We are also launching towards the east.
Allez, me voilà, donc écoutez, bienvenue à tous, bienvenue pour ce décollage aujourd'hui qui a été repoussé hier. Alors, normalement c'est bon. Quelques réserves quand même, on vient de voir que les panneaux météo étaient ok. Mais on peut se permettre des réserves puisque vous avez vu que ce matin, également Transporteur 7 a été repoussé. Donc bon, écoutez, normalement là pour ce décollage-là, tout va bien. Donc on va voir ce que ça va donner. Allez. Alors par contre, aujourd'hui, comme vous le savez, ce week-end, on a beaucoup de choses à faire. Donc je risque d'être présent seulement pendant le décollage. Donc en espérant qu'il n'y ait pas de retard. Donc également, salut Tortue, salut Aigle, salut tout le monde. Tous ceux qui sont présents dans le chat et qui sont également sur le direct. Donc nous avons un petit décollage maintenant dans 4 petites minutes. On va pouvoir également relire approximativement, je vais vous relire vite fait, allez. Pour son 261e lancement, Ariane 5 devra lancer la sonde JUICE à destination de Jupiter. Je répète encore ce que j'ai dit hier. Alors, tout le monde dit que c'est un vol historique en soi, c'est vrai en ce qui concerne l'ESA, mais pas pour la conquête spatiale. Je le répète encore une fois, souvenez-vous, l'Antonov qui avait été détruit, souvenez-vous au début de la guéguerre entre... enfin bref. Alors, je sais... Ouais, non, c'est plus le même. Bref... C'est notamment l'avion qui transportait les navettes Buran. Donc je disais, ce n'est pas non plus une révolution, puisque souvenez-vous, il y a 2 ans, SpaceX avait envoyé la sonde Lucie en direction des lunes de Jupiter. Donc on y retourne. Allez, JUICE est une sonde sélectionnée par l'ESA comme la première mission de grande envergure du programme cosmique Vision 2015-2025 de l'ESA. Elle doit étudier Jupiter et ses grandes lunes glacées, Callisto, Ganymède et Europa. JUICE entrera en orbite autour de Ganymède au cours de sa mission. Voilà, on pourrait dire, le petit résumé de cette mission. Donc écoutez, installez-vous. J'espère qu'il n'y aura pas de retard, j'espère que ça se passera bien. Vous m'en voudrez pas, hein, à partir d'un certain moment, je serai absent. Je vous laisserai encore avec le direct, bien entendu. Parce qu'on vous prépare de grandes choses pour ce week-end. Allez, on va rester avec les dernières explications et puis écoutez, on va attendre avec impatience le décollage. Allez, ça s'approche, on est à moins de 3 minutes. Le petit paresseux. Ah oui, je sais pas si vous avez vu hier l'information, le paresseux qu'on vient de voir actuellement à l'écran, et ben en fait il a été récupéré par les équipes d'Ariane Group parce qu'en fait il s'était avancé sur l'aire de lancement, il voulait voir de plus près le décollage de l'Ariane 5. Je sais pas si vous avez vu traîner l'info hier sur internet, mais le petit paresseux, il a été jusqu'à l'aire de lancement de la fusée. Il faudrait même que je vous mette une photo, je pense que je vous mettrai la photo ce week-end, si j'ai pas le temps, on va dire sur l'onglet communauté, mais c'était assez rigolo à voir. Allez, 2 minutes avant le décollage.
Because trust me, you feel it. What are we going to see in the last few seconds before liftoff, Raphaël?
Well, everything is going to happen quite quickly. So, like I said, the electrical power supply switch
Alors,
from
Aigle, qu'est-ce qu'il nous dit de beau, Aigle? Fun fact, le dessin sur la coiffe, c'est un enfant qui a gagné un concours pour avoir son dessin d'affiché sur la coiffe. C'est génial, ça. C'est génial. On devrait faire de plus en plus de choses de ce genre. En tout cas, pour ma part. Allez, 1 minute 20 avant le décollage de JUICE, du coup, la fameuse fusée historique. Non, je me moque un peu, pas du tout. En ce qui concerne l'ESA, c'est génial. Effectivement, c'est un programme historique, mais au vu de la conquête spatiale, bon, je pense que la mission Lucie a beaucoup plus d'importance que la mission de JUICE. Mais en ce qui concerne l'Agence spatiale européenne, effectivement, nous sommes sur une grande avancée. Mais au point de vue, voilà, espace, conquête globale, personnellement, je pense que la sonde Lucie a beaucoup plus d'entrain et beaucoup plus d'importance que celle-ci. Les missions sont différentes, mais bon, voilà. Clairement, c'est trop bien. Allez, c'est parti, nous sommes à 30 secondes. Et bien écoutez, comme d'habitude, on va augmenter le son au moment du décollage. On se retrouve juste après. Et comme je vous l'ai dit, moi, malheureusement, dans 6 petites minutes, donc on devrait déjà être passé en image de synthèse, je devrais vous quitter, je vous laisserai le direct. Mais on va vivre ça quand même ensemble. Allez, attention, j'augmente le son. Bon décollage à tous, profitez bien. Et puis go!
À tous de vidéo, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage AP, décollage. La propulsion est nominale.
Allez, l'Ariane 5 qui vient de décoller sans encombre. Alors, n'empêche, on est quand même dans une couche assez épaisse de brouillard. Mais écoutez, le lancement, pour l'instant, a l'air réussi parce qu'on n'a pas de télémétrie. Donc, vous savez, avec les vieux souvenirs de la Vega C qu'on a eu il y a quelques mois, on peut toujours s'attendre à des surprises. Mais écoutez, pour le moment, tout a l'air tranquille. Tout a l'air de bien se passer. De ce qu'on peut voir.
In Kourou, there are many places from which to watch these launches. As you can see, the beach, any place. And here we have a glimpse again of the rocket. Raphaël, it's an amazing sensation.
Allez. Ouais, vous pouvez voir la couche quand même épaisse de nuages, sûrement la même, enfin peut-être pas la même, mais en partie qui a pu empêcher le décollage de Transporter 7 tout à l'heure.
So the video said that the trajectory is nominal, which means that it's working perfectly, it's going as planned.
Allez, et cette fois-ci nous sommes passés en image de synthèse. Dans très peu de temps, on aura la séparation des boosters, puis de la coiffe. Allez. On est pour l'instant à une altitude de 60 km. Vitesse 2 km par seconde. Allez, séparation des boosters.
Séparation des EAP.
Et ça y est, on va se séparer de la coiffe également dans très peu de temps. Allez, c'est une histoire de quelques secondes. Le directeur des opérations va donner le go.
La trajectoire est nominale.
Là, on a atteint l'espace, 100 km, séparation de la coiffe. Ça y est, on y est bientôt. Go!
Tous les paramètres bord sont nominaux.
Séparation réussie. Bah écoutez, ça y est, on a la télémétrie, on peut voir, bon c'est de la synthèse, hein, mais on peut voir en tout cas que l'Ariane 5 suit sa courbe. Vous pouvez le voir sur le petit écran qui est en haut à gauche, c'est la petite courbe que vous voyez. C'est l'Ariane 5 et la trajectoire qu'elle doit suivre, donc en vert, et elle est en jaune. Donc elle se superpose très bien.
La propulsion est nominale.
Bah écoutez, pour l'instant, lancement parfaitement mené par Ariane 5. On va suivre les prochaines étapes avec impatience. En ce qui me concerne personnellement, je vais bientôt vous laisser là. Je laisse tourner le direct. Je vais rester avec vous encore quelques petites minutes. Puis vous inquiétez pas, on se retrouve prochainement. N'oubliez pas lundi, Le direct est déjà programmé, s'il n'y a pas de changement. Bon, pour l'instant, j'ai pas envie de faire peur, mais tout le monde a programmé le décollage du Starship pour lundi, mais enfin, comment dire, c'est ce qui a été annoncé par SpaceX, mais le problème c'est que pour l'instant la date n'est pas officiellement confirmée, donc elle peut très bien encore être décalée. On n'a pas de go pour la date, si vous voulez, on est toujours en attente de confirmation. Ce qui ne veut pas dire que ça ne va pas décoller lundi, ce qui veut dire que ça peut probablement encore changer. En tout cas, merci à tous ceux qui sont présents sur le direct. Et vous inquiétez pas, à partir de la semaine prochaine, vous aurez énormément de contenu riche et varié. Il y aura de l'espace, il y aura de l'event, il y aura un peu de tout. Tout le monde en prendra. Eh ben écoutez, en ce qui me concerne, je vais vous laisser là. Je vous laisse avec les images d'Ariane 5. Je vous remercie une dernière fois d'avoir été présent. Donc voilà, malheureusement, il n'y aura pas de direct et pas de vidéo ce week-end. Vous inquiétez pas, à partir de lundi, déjà, si on a le Starship dès lundi, ça va envoyer. Donc voilà, week-end tranquille en ce qui me concerne, enfin tranquille. Sur YouTube, on va dire, parce qu'en réel, ça sera pas pareil. Mais on se retrouve dès lundi et je peux vous garantir que ça va carburer bien comme il faut. Sur ce, eh ben écoutez, je vais retirer ma caméra et puis on se retrouve dès lundi sans problème. Salut à tous.
Again from the DDO is the acquisition by our downrange station of Natal. That is located in the on an island in the middle of the Atlantic. I'll just wait and hear that from the DDO. He may not have confirmed it orally, but by now it is.
Just to explain, all along the route eastwards, Ariane is tracked from the ground. So the launcher's functions and vital signs are recorded and sent back to a network of stations that keeps constant watch on the health of the launcher
Acquisition
systems.
par la station télémesure de Natal.
And we have
it.
the confirmation that the first...
Apologies, of course, I did not mean Ascension. I meant Natal, over the border in Brazil, of course. That's the second downrange station.
And just so you know, in all, that's about 1,500 parameters that is collected.
Collected, my goodness. So that there's no way these
La trajectoire est
1,500
nominale, tous les paramètres bords sont
parameters can be
normaux.
analyzed in real time, Raphael. What happens to them?
Well, the complete analysis is carried out in the weeks following the launch by a dedicated team. They provide a wealth of information about how the vehicle performed during its mission. And so this is why we constantly, improve our knowledge of a launcher, launch after launch. And then that's why Ariane 5 is such a reliable launcher.
And so you were talking about the stations, and it's a little bit, you were saying to me earlier when we were chatting, it's like a relay race, these stations, isn't it? These downrange.
Yeah.
You were listening to the DDO. What did he say? I didn't hear him.
He said that all the parameters are working perfectly.
Nominal, that's what we like to
the
hear.
flight is perfectly smooth. So yeah, this is like a relay race with one telemetry station passing the baton to the next one, because we want to keep full visibility of the launcher in all dynamic phases of the flight. So the first stations to pick up the data was Galileo, right here in Kourou, followed by Natal in Brazil, then the island of Ascension in the middle of the Atlantic, and followed by Libreville in Gabon, and finally Malindi in Kenya.
As the launcher crosses
Trajectoire
Africa.
nominale, tous paramètres nominaux.
So we'll have 3 different, very short sequences right now.
Coming up.
The cutoff of the main stage.
We should hear
then
that.
the jettison of the main stage, and then the ignition of the upper stage. So it should be confirmed.
Extinction Vulcain. Séparation EPC.
And the ignition coming up.
Yep. Waiting for the
Allumage ESC confirmé.
That's a very good news. That's a very
You
important
should see the
step
smile on
towards the
Raphael's
sun.
face. You can't because we're in our little booth. Because we forgot to mention that we are now in the sky booth, where we have a fantastic view over Jupiter, where we can see the crowds gathered. And yes, and so you cannot see the smile on Raphael's face, but he is delighted that this stage has gone perfectly.
Yeah, the ignition of upper stage is absolutely key, because it's always quite a little bit tricky to ignite a liquid stage in the emptiness of space. I told you that on the ground we wait for a few seconds to check that the Vulcan engine is correctly ignited
Fin de visibilité par la station de Galileo.
before liftoff. But in space, it's just not possible to do that. You cannot send somebody to repair the engine. Also in zero gravity, the propellant is floating in all
Le pilotage
directions.
est calme.
The thermal environment is also not the same as it is on the ground. So, you know, there are many factors that make it quite
Trajectoire
challenging
nominale, tout paramètre bord nominaux.
and complex to ignite the engine in space.
So we were mentioning earlier, this is the penultimate Ariane 5 launch, which for more than a quarter of a century has provided Europe with reliable and independent access to space, which Josef Aschbacher was talking about earlier. Ariane 6 will be taking over. Europe's best engineers are building on the success of Ariane 5, and there's already a fully integrated Ariane 6 on the launch pad right here in Kourou. You're going to tell us about that, Raphael. So can you take us through the latest developments with Ariane 6?
So last year was quite exciting for Ariane 6 with the start of what we call the combined test, corresponding to the meeting between the launcher and the launch pad here
La
in
trajectoire est
Europe
nominale, tous les
Spaceport.
paramètres bord sont nominaux.
Here we see a fully representative version of Ariane 6, which has been assembled with the main core raised vertically, directed on the launch pad. The upper composite was then hoisted and mated on top of the launcher. This operational scheme is actually a big difference with respect to what is done with Ariane 5. It is made possible thanks to this mobile gantry, which will obviously be removed during launch. And also, 2023 is going to be also a busy year for Ariane 6, obviously. In January, the launcher was connected to the control bench, and a first power test was performed. Then dry run will be performed, followed by the actual fueling operations of the central
La
core.
trajectoire est nominale, tous les paramètres bord sont nominaux.
Teams will also perform hot firing tests of the lower stage engine, Vulcan 2.1, including a long firing test. And hot firing tests of the upper stage were successfully performed in 2022 and beginning of 2023 in Lampershausen at the German Aerospace Center. Next ones are under preparation.
calme.
So launcher elements that will be used for the Ariane 6 first flight will arrive in French Guiana using the new generation canopy vessel, which will be equipped with sails and hybrid
La
propulsion,
trajectoire est nominale, tous les paramètres à bord sont nominaux.
so that we can start the first real launch campaign of Ariane 6. And so today, the prototype of Ariane 6, stands on the launch pad, ready to continue the combined test. So good luck for this very ambitious and incredible program.
And Raphael, we heard while you were explaining all of this, we heard that the DDO called out the loss of signal with the Natal tracking station.
Suite à
Now,
la fin d'acquisition par la station de Natal.
there we go. And we didn't hear that it hadn't been picked up by the next station. Is that normal?
This is perfectly normal to have short visibility holes during non-dynamic phases of the launch. In this case, we have no visibility for just 63 seconds before the Ascension ground station picks the signal back. So this should come in any seconds now.
Acquisition de la télémesure par la station d'Ascension.
Your timing is perfect.
Confirmed.
So we've been picked up by the next downrange station, that is Ascension, the tiny little island in
La
the
trajectoire est
South
nominale,
Atlantic,
tous les
and
paramètres à
everything
bord
is
sont nominaux.
nominal, the DDO is telling us. So from what I understand, we're going back to Ariane 6, there's a very healthy order book already for Ariane 6 launches, Raphael.
Yeah, Ariane 6 is already quite successful on the market, with already 28 launchers sold for both institutional and commercial customers. It is a very versatile, flexible launcher, perfectly suited for complex missions and satellite constellations deployment thanks to its high lift-off capability and its reignitable upper stage engine.
La trajectoire est nominale, tous les paramètres bord sont nominaux.
It's nice to hear the regular updates from the DDO that everything is going to plan. For those of you who are joining us, Ariane 5 lifted off 14 minutes ago, just over 14 minutes ago, from the European spaceport here in French Guiana, carrying ESA's Jupiter Icy Moons Explorer into outer space. We're bringing you this live show from the Jupiter control room, where the operational teams are overseeing the mission's progress. JUICE is due to separate in about 13 minutes' time, but this is just the start of its long journey on its way to Jupiter. Let's find out more about the tech on board that will help it fulfill its mission.
La propulsion est nominale, le pilotage est calme.
At the heart of the JUICE mission, led by ECA, is a giant bird-like spacecraft with large solar panel wings stretching out on either side of its main body. With a mass of 6,100 kilos at launch, JUICE is a heavy spacecraft carrying 10 high-precision instruments, including the most powerful remote sensing, geophysical and in-situ payloads ever flown to the outer solar system.
Building a spacecraft which has to fly around Jupiter is a challenge. To operate a spacecraft, you need energy, you need power. And normally we get power from the sun using solar array. But around Jupiter, there is not much sun. Therefore, the solar array has to be very big. There is also another challenge. All the stuff that we built there has to survive very low temperature. And the third one is that the environment around Jupiter is very radioactive. That's why I think the solar array, which is very exposed and put together these three difficult technology, is really a great piece of engineering. Maybe a piece of art.
The instruments were contributed by the JUICE mission's scientific partner. The spacecraft was developed and built by Airbus, and Ariane Group's Savoir-Faire equipped JUICE with the chemical propulsion system that will drive it to Jupiter and its icy moons on an 8-year cruise.
We will provide the propulsion system for JUICE, which ensures that after leaving the launcher, it arrives correctly at Jupiter's moon and can work properly there. It's a fascinating thing, especially because the technical requirements of such a long journey, with so many constraints to consider, challenge each of us in a unique way.
Engineers have devised advanced technological solutions so that JUICE can operate in extreme environments, face Jupiter's high radiation belt, the long distance and harsh temperatures. Its 2.5-meter diameter antenna will send the data JUICE collects back to mission control, although it can take close to an hour to travel to Earth. The European mission JUICE is going to be a real revolution. Its collection of valuable data will be used by scientists for years to come and help unlock some of the greatest mysteries of the universe.
So, Raphael, JUICE is an emblematic European science mission. So what is it about this particular mission that inspires you as a rocket scientist?
Well, dream. And dream has always been a very strong driving force.
Acquisition par la station télémesure de Libreville.
For me, but also for, I think, everybody who works in the space industry. And, if we go on a more personal note, actually, before working at Ariane Space, many years ago already in my life as a space writer, I remember that one of my first real article I wrote was about Jupiter's icy moon and the preparation of the JUICE mission with a focus on the moon Europa. And you can imagine that I would have never thought back then that I would be here standing at Kourou Spaceport in the Jupiter room to comment on its deployment into space. And I think I'm not mistaken when I say that all my colleagues are inspired by such emblematic mission. It really gives us an extra boost each time.
And especially when it comes to a mission aimed at looking for signs of life, that is just something else. It's difficult to actually fathom.
Can you, I mean, yeah, the ambition of JUICE, and it's a very complex mission, by the way.
La propulsion est nominale, le pilotage est calme.
So everything is nominal, but thinking that one probe is going to be around the moons of Jupiter, which are unexplored worlds with oceans of liquid water under the ice
La
surface,
trajectoire est nominale, tous les paramètres bord sont nominaux.
where exobiologists expect to find some
Nous sommes go pour la mise à feu. H-.
15, 14,